How to graph equations of the form y equals m times x plus b by hand. This is part of the Family of Functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during the video. We will begin by doing an investigation. Let's see if there's a relationship between the equation of a line and key points or properties of the graph of the line. We'll start with an equation of a line in standard form. And then we're going to solve that equation for y. So here's our equation. 3x minus y equals -1 is in standard form. To solve this equation for y, we'd like you to pause to answer, resume when you're finished. So first thing I would do is subtract 3x from both sides, and then either take the opposite of each term or multiply each term by -1 to get what y is equal to. So this equation is solved for y. Sometimes we say it's solved for y in terms of x. So we have the equation in standard form, the equation solved for y. Recall that these two equations are equivalent forms of each other. And what we mean by that is the equations do look different, but they describe the same set of points. Let's look at the graph of this equation, and we're just going to go ahead and graph it. We think you already know how to do that, but we want to look at the graph and see how it relates to the equations. So here's the graph of y equals 3x plus 1, or 3x minus y equals -1. Using the graph, copy and complete the following. We want you to write the equation of the line solved for y, write the slope of the line, and write the y-coordinate of the y-intercept. So go ahead and pause to answer this, resume when you are finished. So this is the equation solved for y equals 3x plus 1. To find the slope, I picked 2 points. Notice that the slope is a positive number. It is slanting uphill as we look at it from left to right. And it has a change of y of 3 and a change of x of 1. So it's going to be positive 3 over 1, or just 3. The y-coordinate of the y-intercept, crosses the y-axis at 0, 1, and the y-coordinate is positive 1, so 1. So what I'd like you to do is look for patterns in these last 3 answers, and so I highlighted them so you could see that. So go see if you can find some patterns, pause to think about it, resume when you're finished. Now, before we generalize, let's look at a couple more examples. So here's another equation in standard form. I'd like you to solve this equation for y in terms of x. Pause to do that, resume when you're finished. So I subtracted 2x from both sides. Then I divided each term by 3. And then when I simplified, I got y is equal to -2/3 x plus a positive 2. So here are 2 equations. Again, these are equivalent forms of each other. That is, they look different, but they describe the same set of points. So let's look at the graph of this equation. Again, we'll just go ahead and do that for you. And there's the graph shown at the right. So again, using the graph, copy and complete the following. Write the equation of the line solved for y, write the slope of the line, write the y-coordinate of the y-intercept, pause to answer these questions, and then resume when you're finished. So the equation solved for y, of course, is right here. The slope of the line, you'll notice the line is slanting downhill, so it has a negative slope. I picked these 2 points. Change in y is 2, change in x is 3, so the slope is -2/3, -2/3. Sloping downhill, slanting downhill. And the y-intercept here occurs at 0, 2, and 2 is the y-coordinate of the y-intercept. So what I'd like you to do is look for patterns in those last 3 answers, and I'll highlight them for you. Pause to answer that, resume when you're finished. And before we generalize, we're going to look at another example. Here's an equation in standard form, 3x minus 4y equals 8. Again, I'd like you to solve this equation for y. Pause to do that, resume when you're finished. So I subtracted 3x from both sides, then divided each term by -4, the coefficient of y, each term, and then simplifying, y is equal to positive 3/4 x minus 2. So here are our equations in standard form and solved for y. Recall these are equivalent forms of each other, which means they look different, but they describe the same set of points. And as we did previously, we're going to go ahead and just graph it for you. And we're going to ask you to use the graph to copy and complete the following questions. So go ahead and copy and complete the following questions. Pause to answer those questions. Resume when you're finished. So here's the equation solved for y. Y equals 3/4 x minus 2. The line is slanting uphill, so the slope is a positive number. Change in y of 3 for every change of x of 4. So positive 3/4 is the slope. The y-intercept graph crosses the y-axis at 0, -2, and the y-coordinate of that point is -2. Look for patterns in those last three answers, and I'll highlight them again. Pause to answer when you found the patterns, and resume when you're finished. So let's summarize our findings. So here are the three graphs, the three equations solved for y. The slopes of the lines we calculated before. I'm just putting them back down here. And the y-coordinate of the y-intercept. So these are the things we just did. Those should be on your paper right now, but we're looking at them side by side. So what patterns, again, do you notice? This is a time where I do want you to generalize based on those three examples. Pause to answer, resume when you're finished. So you'll notice here, there's the slope, there's the slope, there's the slope, there's the slope in the equation, there's the slope, there's the slope in the equation. So it appears, well, I'll give you one last chance in case you didn't see that before. So the slope is the coefficient of x when the equation is solved for y in each of these three cases. Now, what about the y-coordinate of the y-intercept? Looking for patterns here. So what patterns do you notice? Pause to answer, resume when you're finished. And it turns out that the y-intercept is the constant that's added to this x term in each case. In this case, we're adding a -2, same thing as subtracting +2. So when the equation is solved for y, the coefficient of x is the slope, which we usually abbreviate with the letter m. And the constant added to the x term is called the y-coordinate of the y-intercept, which we usually designate with the lowercase b. So when the equation is solved for y, the coefficient is the slope m, the coefficient of x is the slope m, and the constant added to the x term is the y-coordinate of the y-intercept, designated lowercase b. For example, here's an equation that's solved for y. What's the slope? What's the y-intercept? Well, the coefficient of x5 is the slope of the line. M is equal to 5. And the constant added to the x term, -4, is the y-coordinate of the y-intercept, which is b, which is equal to -4. Generalizing, an equation is solved for y. We're going to say y is equal to m times x plus b. The coefficient of x is always a slope, m. The constant added to the x term is always the y-coordinate of the y-intercept, designated lowercase b. So y equals mx plus b is one of the most powerful and useful equations in mathematics. The equation is referred to as the slope y-intercept form, or sometimes it's called slope-intercept form. Y equals m times x plus b. Let's use this form to quickly graph equations of lines. Quickly. Example 1. Let's graph y equals 1/2 x plus 3 using this slope y-intercept form. First, we need to solve the equation for y, but it already is. We need to identify the values for m and b. So what I like to do is write the equation right beneath it, and the coefficient of x is m. The number added on there at the end is b. And so m is positive 1/2 and b is equal to positive 3. Remember, press pause anytime if I'm going too fast. Third, we're going to plot the y-intercept at the coordinates 0, b, in this case 0, 3. There it is. That's the y-intercept point. That's 1 point on the line. And we're going to use the slope to plot a few more points. Really, we only need one more, but I like to get a few more. So the slope is 1/2, positive 1/2. So that's a change of y of 1 with a change of x of 2, which means up 1, right 2 from that point. And if I do another one, up 1, right 2 again, we get a third point. Recall that 1/2 could be written as -1 divided by -2, which means the change in y would be down 1. The change of x would be left 2. So we could get another point there. And do it one more time. Down 1, left 2. And so there's 5 points that are collinear. And so now we can go ahead and draw the line. And that's the graph of y equals 1/2 x plus 3. Please press pause as needed anytime. And I will point out we really only needed 2 points to determine the line. I kind of got carried away. I usually like to get at least 3. Example 2, graph y equals 4x plus 2y equals 10. I'd like you to do a little bit more on this one. So I'm going to solve the equation for y. Pause to answer, resume when you're finished. So I'm going to subtract 4x from each side. Divide each term by the coefficient of y, which is 2. And then simplify each term. Y is equal to -2x plus positive 5. So the equation is solved for y in terms of x. Identify the values for m and b. So go ahead and do that. Resume when you're finished. Again, writing that y equals m times x plus b right below it, I can easily pick out that m is -2, b is positive 5. So we can plot the y-intercept. Go ahead and do that. Pause to answer. Resume when you're finished. So 0, 5, I'll plot that point. And I'm going to use the slope to plot a few more points. So pause to do that. Resume when you're finished. Slope's -2. I'll write it as -2 over positive 1. So the change in y is down 2. Change in x is right 1. So the line will slant downhill from left to right. I can do that again, down 2, right 1. Or I could think of the slope as positive 2 divided by -1. So the change in y would be up positive 2, change in x left 1. And do that one more time. Up 2, left 1. We've got 5 points that are collinear, can draw the line. Again, we only really needed 2 points, but I got kind of carried away. Press pause as needed anytime. Now you try some. Graph this equation. You need to do it completely, and I'll just show you the answer. Pause to answer, resume when you're finished. All right, so the equation was already solved for y, so I can pick out m to be -3/2. B is equal to +1. So the y-intercept is at 0, 1, right here, that point. And then I'm going to use the slope to be change in y, -3, change in x2. So that would be down 3, right 2, down 3, right 2. Or I can think of it as +3, up 3, -2, left 2, up 3, left 2. As you can see that the line definitely is slanting downhill from left to right. Press pause as needed. Here's another one to try. Pause to answer, resume when you're finished. So I solved for y. You can see how I did that. Pause as you need to do so. The slope is +3/5. The y-intercept value is -3. So we plot 0, -3 on the y-axis. And the slope is 3/5, up 3, right 5, up 3, right 5. Or I could think that is -3 divided by -5, down 3, left 5, down 3, left 5. And those are my points that are all collinear. Press pause anytime. And the last one, 10x equals 4y. Pause to answer, resume when you're finished. All right, solve for y. Y was equal to 5/2 x. I need to put a +0 for a lot of people, so I'm going to put that in so that I can find that b is equal to 0. So the y-intercept is at the origin. Slope's +5/2. It's going to slant uphill from left to right. Change in y of 5, change in x2, 5/2. But I can also write it as -5 divided by -2, down 5, left 2. Down 5, left 2. And those are my 5 points that are collinear. Press pause as needed.